Next, the rate constant K1 of a reaction is found to be double that of rate constant K2 of another reaction. The relationship between corresponding activation energies of two reactants E1 and E2 can be represented as. So here rate constant K1, that is double than that of K2. Okay. When rate constant is more, activation energy is less. Okay. As rate increases, activation energy gets decreases. Okay. When K1 is more, E1 is less. So that's why, what is the relation between activation energies? E1 is less than E2. Okay. Next, the rate expression gives the relation between rate of a reaction and what is rate expression? Rate law. Rate law or rate equation, that is also called as rate expression. So R is equal to K into concentration to the power N. Okay. So rate expression gives the relation between rate of a reaction and a concentration of reactants. So A. Next, for a reaction Kt plus 10 degrees centigrade by Kt degrees centigrade is equal to X. X is temperature coefficient. When temperature is increased from 10 degrees centigrade to 100 degrees centigrade, rate constant K increased by a factor of 512. So, what is the value of X? So, here 10 to 20 degrees centigrade. Okay. So, that is equal to X. Okay. And 20 to 30 degrees, it will become X square. Okay. 30 to 40 degrees, it becomes X cube. 40 to 50, X to the power 4. Like that, 90 to 100, it becomes X to the power 9. Okay. X to the power 9. So, X to the power 9 is equal to 512. So, X to the power 9, that is equal to 512. Okay. So, we can write 512 as 2 to the power 9. Okay. 2 into 2 into 2 into 2 to the power 9. So, X to the power 9 is equal to 2 to the power 9. So, as powers are same, bases must be same. So, that's why X is equal to 2. Okay. Option D is correct. So, the rate constants of a reaction at 300 Kelvin and 280 Kelvin, they are K1 and K2. And what is the relation between K1 and K2? So, at 280 Kelvin, rate constant is K2. Okay. Then at 290, it becomes 2K2. It becomes double. Why? Because for every 10 degrees rise temperature, rate becomes double. So, it becomes 2K2. And for another 10 degrees, so at 300 Kelvin, it becomes 4K2. So, at 300 Kelvin, what is rate constant? K1. So, K1 is equal to 4 into K2. Okay. Next, a catalyst in a chemical reaction does not change. Catalyst does not change. Average energy of reactants and products, enthalpy of reaction, activation energy of reaction, both A and B. So, 4 options are there. So, here catalyst that changes rate of reaction by changing the path and by decreasing the activation energy. So, catalyst changes activation energy of the reaction, but it does not change average energy of a reactants and products and also enthalpy of a reaction. So, what is the option here? D, both A and B. Next, which of the following does not affect the rate of reaction? So, rate of reaction that does not affect by enthalpy of reaction. Enthalpy of reaction does not affect the rate of reaction. Okay. So this is purely concept basis. Next, for N2O5 decomposition. N2O5 in carbon tetrachloride CCl4 decomposes into NO2 and half O2. Here rate constant is 6 into 10 to the power minus 4 second inverse. So this is at 350 Kelvin. Okay. And K is equal to 1.2 into 10 to the power of minus 3 second inverse at 360. For 10 degrees rise of temperature, it becomes double. It becomes 6, here 6 into 10 to the power of minus 4. Here 1.2 into 10 to the power of minus 3. And we can write 12 into 10 to the power of minus 4. Okay. So it becomes double here. Okay. So at 360 Kelvin, rate becomes double. When temperature is changed to 380 Kelvin. Okay. So at 360 it is 1.2 into 10 to the power of minus 3. For every 10 degrees rise of temperature, rate becomes double now. So at 370, okay, it becomes 2.4 into 10 to the power of minus 3 second inverse. It becomes double. Okay. And at 380 Kelvin, it becomes 4.8 into 10 to the power of minus 3 second inverse. Okay. So what is the option here? D. 4.8 into 10 to the power minus 3 second